Hello and welcome to seventh lecture. Let me see. Yeah, seventh lecture in fifth chapter of our comprehensive AI ML DS course. Now, from these, as such, we are doing advanced usage of Numpy library. So, from these, we are slightly going off track. I would not say off track because still Numpy only will be used, but we want to learn a little bit of statistics. And please remember that this much or slightly even more than this, statistic is very important for becoming a data science or machine learning expert. And because you may become expert in developing a system and ML ops, that is machine learning operations, so that you can design a big, nice app, complicated app, and you may deploy it on the most advanced cloud like maybe AWS, Azure, GCP, anywhere. But the problem is that for your machine learning model to give accurate predictions, you have to first design a good hypothesis, you have to understand your data, and you have to then make a model which explains the larger variance of your data. That is, it can explain majority of observations in the data. So you have to learn about data, understand data, get a feel for your data. Before, after that, all the machine learning and data cleaning and model development and all that will start. So for getting a feel for data, you have to learn all this. So at present, I'm doing this left side in the yellow or orange kind of thing. Central tendency, mean, median, mode, and geometric mean. These quartiles we will do here with range and interquartile, range and variance. Okay, because actually it is not related here. It is by mistake some put it here. Okay, it should be here. Fine. So in short, this orange color portion. These are called measures of central tendency. Let us first try to get intuitive understanding for small number of observations. So perhaps let us say one this kind of case where this is the serial number of observations. Suppose there are 13 observations and these are xi. Xi means I equals 1 to 13. So this is x1, 10, x2, 20, x3, 30, 40, 50, 60, 70, 80, 90, then again 10, 20, 10, 10. Okay, that is what are the xi's. Before I do anything, what I do is arrange them in ascending order. Now I can arrange in descending order also, but in short, some order, because here up to this is 10 to 90 is actually just increasing, but after that again 10 comes, again 20 comes. So you have to first count how many 10s are there. So 1 here, then 1 here, 2 and 1 here. So 4 times 10, so 10, 10, 10, 10. Then there is 20, 1 here at the top and 1 here at the bottom. Okay, so then 2 times 20. Thereafter you can just write in ascending order, because thereafter each observation is only 1, 30, 40, 50 up to 90. Fine. Now first let's define what is mean. Then mean is simply, very simply defined as the number of observations divided by, the sum of observations divided by number of observations. So sum of observations, I am writing with my mouse, so pardon for that, divided by number of observations. That quantity is called mean. And usually if observations are xi, x1, x2 up to then this mean is represented by x bar. Okay, like that. If observations are y1, y2 up to that, then that will be called y bar, and so on. So this is what the mean is. Now here in this case, I have arranged them in ascending order. Actually for mean, ascending, descending is not required, but it is always good to cultivate that habit first. Sorting, that is in Excel, whatever observations are there, you just apply the sort function here. Okay, so then 10, 10, 10. Now if I do the sum of all this, then that is 500. So the sum of observation is 500 and divided by number of observations are 13. And 500 divided by 13, if I do, let me do it in browser itself. So any browser can always do the calculation. 500 divided by 13 is 38.461. Okay, so here this is the 38.46 here. Okay, so mean x bar, in my case I am getting as x bar equals, now the sum of observations divided by number of observations, that is symbolically written this way: sigma xi divided by n. N is the total number of observations. Some people even write even more specifically, sigma I equals 1 to n. So I starts from 1 to n. Now in my case n is 13 and sigma symbol means take first observation, where put I is equal to 1, so x1, so this is my x1. Then take second observation, so x2, so this is my x2. Then take third observation, so this in blue, that is my x3, and so on up to x13, because n is equal to 13. And do this sigma says add all those and divided by 13. So x bar would be equal to 500 because the sum I have already calculated for you. Here it is here, and divided by 13. And the division also we just now did in the browser window. It was 38.46. Okay, so 38.46 was the division. So x bar in my case the mean is 38.46. Or can I write just 38.5 rounding? Okay, fine. Now then, this is just one type of mean. This is called arithmetic mean. Now there is another word for median. For median, what you have to do is, and for median, this arranging in ascending or descending order is absolutely compulsory. Then you have to find the middle element. Now middle element means what? Here if there are 13 elements, then what I can do is, I can take 6 elements from top. So I think this in the blue rectangle, they are the 6 elements from top, correct? And I can take 6 elements from bottom. So this in the red rectangle, they are the 6 elements in the bottom. Okay, and then you have to do this. Find this. This is the median of this data set. Okay, so that means go on taking mentally cancelling one from here, 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 and finally whatever remains in the middle, that is the median. So what is the median for this data set? Then the median is 30. Okay, so the median is 30. Now the question is, here the number of observations are odd. Okay, so I could easily 13 observations. So therefore I could remove 6 from that side and 6 from this side after arranging them in ascending order. So one middle element remains. What to do if number of observations are even, say 12? Because then what will happen? If I say there are 12 observations, that means this last one is not there. This last one, this is suppose not there. So in that case, what I will have to do? I will have to, let me again clear. Make median was 30. Please remember. Okay, let me clear all the math. Okay, and mean was 38.5. Remember that, and median was 30. Let me clear all this math. And suppose this last observation was not there. Now in that case, if I try to find the middle element, then I will take 5 from the top and 5 from the bottom. Because as I said, the way is that cancel one observation mentally from this side, cancel one from that side, cancel one from this side, cancel one from that side. Now you can cancel 5 only, because if you cancel this, then only 1 remains. But there are actually equal numbers cancellations from both sides must occur. So 5 and 5. So then here, when the total number of observations are 12 here, because remember the last one I have deleted. Okay, so in that case, that if the so this red is actually here, not the last one is not included. Okay. So you can see each red rectangle has 5 observations. These are 5 from top and these are 5 from bottom. 40, 50, 60, 70, 80. And these are 10, 10, 10, 10, 20. Okay. So 2 are remaining in the middle. So what is my median? So then it is simple that in that case the median would be equal to the arithmetic mean of these 2. So arithmetic mean of these 2 means sum divided by total number of observations. So that is 30 plus 20 divided by total number of observations 2. So then 50 by 2. So in that case the median would be 25. But I took odd number of observations. So for me the median was, okay, so I had originally 13 observations, so therefore I removed 6 from the bottom and 6 from the top. So whatever remaining in the middle, that is my median. So median was 30. Fine. Now what is mode? Mode is very simple, the most frequent observation. So that means if these are the data points or numbers, then which number has occurred maximum number of times or more number of times, that is called mode. So that means 10 once, 10 2, 10 3 times, 10 4 times. So 10 has occurred 4 times, 20 has occurred only 2 times, and rest are only 1 time. So here what is my mode? Then this which is occurring the maximum number of times, that is the most frequent element in my data set, that is called mode. So the mode is 10. Okay, so the mode is 10. Fine. Now the question is about how many modes are possible. You should not have idea that only one mode is possible. For this data set only one mode is possible, but suppose instead of 30 and 40 also there would be 20 20. Then in that case 10 is occurring 4 times, 20 will also occur 4 times, because 30 is also 20, now 40 is also 20, and these two 20 are already there. So then in that case 20 will also become mode. So given data set can have more than one mode, and one important thing is mode is always a point or a value which is already part of my data set. while mean is some imaginary value somewhere which may or may not be part of my data set. And same is about median. It may or may not be. Median is always part of my data set. Mode is also always part of my data set. Median may not be, because sometimes, as I said, if there are even number of observations, then you will have to take the arithmetic mean of the middle two observations. So in that case, it is possible that median also may or may not be part of your data set. But mode is always a part of your data set, or one of the observation in your data set. So this is about mean, median, mode. These are very basic concepts. So, but these three are called measures of central tendency. Okay, measures of central tendency. Then there is another called geometric mean. What is geometric mean of two numbers? Then it is simple. If these are two numbers like this, 10 and 40, then the geometric mean is under the root 10 multiplied by 40, and under the root means this is a square root, so 2. Okay, and therefore 400 square root. So the geometric mean is 20. But remember, it is not only true for two numbers. There can be five numbers, a1, a2, a3, a4, a5. Then it would be under the fifth root. Here there would be fifth root, and here product of all those numbers, a1, a2, a3 up to a5. Here there are two numbers, so product of two numbers and then square root. If three numbers would be there, then product of three numbers, cube root. If four numbers would be there, then product of four numbers and then fourth root. If five numbers would be there, then product of five numbers and then its fifth root. Fifth root means raised to power 1 by 5. Okay. Similarly, there is another word, harmonic mean. Harmonic mean, it is not here visible, but it will come later on. So harmonic mean is defined in this manner. To find harmonic mean, you don't have to use the numbers, but you have to use reciprocals of their number. And by adding the reciprocals of the two numbers, you will get the reciprocal of your harmonic mean. This is the reciprocal of your harmonic mean. This is the reciprocal of first number, and this is the reciprocal of second number. Now, if I simplify this, then clearly the LCM is 40, or you can also write 40 plus 10, 50 divided by 400, or this is 5 by 40. But that is reciprocal of one harmonic mean. So H would be 40 by 5, and therefore H would be 8. Okay. So harmonic mean of these two observations is 8. Now again, here also the formula remains same. If instead of two observations, suppose there are 5 observations, n1, n2, n3, n4, and n5, then 1 upon h is equal to 1 upon n1 plus 1 upon n2 plus 1 upon n3 plus 1 upon n4 plus 1 upon n5. Okay, and then you will do that addition on the right side, and whatever answer you get, that is 1 upon h. So you will do its reciprocal. For two numbers, the harmonic mean can be found by this simple short formula, that the harmonic mean is product of two numbers divided by sum of two numbers. And we will require this later on when we introduce a concept called F1 score. So at that time there is a parameter called precision, P, and another parameter called recall, R. So then F1 score is defined as harmonic mean of P and R. So harmonic mean of P and R means what? It will be P multiplied by R divided by P plus R. So 10 multiplied, here it is 10 multiplied by 40 divided by 10 plus 40, or 400 by 50, or that means 40 by 5, so harmonic mean is 8. But the limitation of this is that it can only work for two numbers, for three numbers, or five numbers. So remember the basic formula also, and remember the short form also. Okay. So these 5 are called measures of central tendency. What 5? 1, arithmetic mean, sigma xi divided by n, sum of observations divided by number of observations. Then median, go on cutting one observation from each side, and whatever remains in the middle, that is the median. If 2 remain in the middle, then in that case take their average, that is the median. Mode is the most frequently occurring observation. Geometric mean of n numbers is equal to product of those n numbers and then find nth root. 2 numbers, then product of 2 numbers and find 2 root. 2 root means square root. Okay. Then harmonic mean, then you will use 1 upon harmonic mean is equal to 1 upon first number. Reciprocal of harmonic mean is equal to sum of reciprocals of original number. So one reciprocal of harmonic mean 1 by s is equal to 1 by n1 plus 1 by n2 plus 1 by n3 plus 1 by n4 and so on. It can have any number of numbers. Okay. So you can find reciprocal and then find h, harmonic mean. For two numbers, reciprocal can be easily harmonic mean can be easily found by product of 2 divided by sum of 2. Okay. So this is measures of central tendency. Now what is the meaning of this? That we try to understand by one diagram. Suppose this is here this one line is equal to 10. So this is 10 first observation. Next 3 more observations are also 10. I am arranging in ascending order. So these are 4, 10. Then the next observation is 22 times. So 20 should extend up to height, double height. So these are 2 20s. Then 30 is extending even more than that. So this is 30. 40 is extending even more than that. This is 40. 50 is extending even more than that. 50. This is 60. This is 70. How many last is 80 and 90? Okay, so this is 80 and this is 80 and 90. So these are my data points. If I find their height, something like a bar chart where I show their height as the magnitude. Okay. So now if someone says what is the mean, or then mean is 38.5. So where will be that 38.5? 38.5 will be, this is 20 and this is 30 and this is 40. So 38.5 would be somewhere on this line, that much height. Okay, then where is this median? Median is 30. So median I am showing by blue color, and this is the median. Okay, then what is harmonic mean for this data set? Then I am showing yellow, black suppose, and I am showing harmonic mean is 8. 8 means just less than 10. Each line in my this diagram, this page is 1, 10. Okay, then what is the harmonic mean is found, and geometric mean is 20. So geometric mean of this is 20. Now for geometric mean, what I can do just to distinguish, I can use maybe a different color. Green is not used. So this is the geometry. Oh, 20 geometric mean. So these lines, these are called measures of central tendency. If these are my data points like this, starting from here to here, then these are some midpoints, roughly some kind of midpoints. Okay, these are some kind of midpoints. This red, blue, green, and this another thin black. These are my midpoints. So these are called measures of central tendency for my data set. Okay. Now we will do this in much more detail by coding also. But first intuitive understanding. Now coding we will do in further next